All right, 7.2b, natural logarithms, expressions, and equations. This is our last piece of information before we take our test. Yay! So after completing this, you should be able to complete your 7.9/7.10 classwork and any remaining questions that you may have on your test review. So we're going to start here with solving an exponential equation. So step 1 is to isolate the exponential by subtracting/adding. Step 2 is to continue by dividing or multiplying to isolate the exponential. Step 3 is to rewrite in log form and use power property to simplify. Step 4 is to solve for variable using inverse operations. And then step 5 is to simplify. And step 6, like always, final step is to check your work. Okay. So rewrite in log form and use power property. This is where we're going to use property numbers 2 and property number 5. Okay. All right, let's get started. So here we have e to the x equals 3/4. So the first step is to isolate the exponential. Our exponential is isolated. So step 1, my pen gets somewhere, is satisfied. Okay. Step 2 is to continue by, if there's anything to divide or multiply with, there's nothing to divide or multiply with. So step 2 is good to go. Step 3 is to rewrite in log form. So step 3 is where we're going to apply property number 2 and number 5 if necessary. So applying property number 2, we have natural log of e to the x equals natural log 3/4. So what you do to one side, you must do to the other side. And just like any other time we've done this, natural log is going to undo e. So we're going to be left with x equals the natural log of 3/4. Okay, so step 4 is to isolate x. And we're like, oh, x is already isolated. It equals natural log of 3/4. So that's our exact. We're going to use a calculator to find an approximate. So we're taking it and putting it into the calculator. So we have a natural log of 3/4. Hopefully you followed along. And you're going to end up with negative 288 thousandths. Okay. So we solved, we simplified. Here we are. So 4 and 5 are kind of joint. So 5, if there was some need for simplify, we would. There isn't. And then step 6 is to check. So if I take the original and I plug it in, do I get the same thing? So let's check. I have the natural log, and I'm plugging in, I'm plugging it into e to the x. So I'm going to have e to the natural log of 3/4. And using property number 1, I know that this is going to undo the natural log, and we're left with 3/4. And like, yay, we're so smart, we did it. Okay. All right, here, step 1. Make sure there's nothing we need to add or subtract away. Check. Step 2, make sure there's nothing we need to multiply or divide away. Check. Step 3 is to apply property number 2 and number 5. So that gives us the natural log of e to the 2x equals what I did on one side, I have to do to the other. The natural log undoes the e, and we're left with 2x equals natural log 1.4. Step 4 is to solve for the x. So I'm going to divide by 2. And I get x equals natural log 1.4 divided by 2. Okay, remember that this could also be written in a different way. It could be written as 1/2 natural log 1.4. It could be written as natural log 1.4 to the half. So just be comfortable being able to identify it in any of the exact forms. Step 5, some other forms being simplified. Step 5. And then step 6 is to check it. So if I want to check it in the original, so I have e to the 2 times I'm going to use 1/2 natural log 1.4. 2 and 1, 2 times a half is 1. E to the natural log undoes it, and I'm left with 1.4, which lets me know that I did it correctly. More. Okay, so notice here we have a little extra happening. So step 1 is to add or subtract away anything so that you can isolate the e. So I can actually subtract 8 away. So that's going to leave me with 2e to the 3x equals 6. Okay, step 2. So for step 2, this is where I'm going to either multiply or divide away. So I'm actually going to divide by 2 on both sides, and that leaves me with e to the 3x equals 3. Okay, so now I'm at step 3, and I'm going to apply property number 2 and number, sorry, I'm going to apply property number 2. I think it's all right. Oh, I forgot what property we're on. Property number 2. So isn't it the natural log of e to the 3x equals 3? This is going to undo, so it undoes my natural log. I'm left with 3x equals 3. Step 4, solve for x, divide by 3, and that leaves me with x equals 1. So if I take, it does not leave me with x equals 1. Natural log of 3 divided by 3. I'm so sorry, y'all. Like that's not what I got in my notes. Because it's not what it is. Natural log of 3, because when I do to one side, I do to the other. And I'm going to take natural log of 3 and divide by 3. And so we have x equals the natural log of 3 to the third, which equals, or 1/3, or however you want to see it. So 3 to the third, 1/3, divided by, all those different ways. So I'm going to put it in the calculator, whichever way you're the most comfortable with. But remember, you should be comfortable seeing it and knowing what it means in different formats. So if I said 1/3 natural log 3 or natural log 3 to the third, please make sure you're comfortable with all the ways. So we have natural log of 3 divided by 3, and that gives me approximately 366 thousandths. Okay, so this is my approximate value. Step 6 is to check yourself. Step 6 is where we check. So if we take natural log of 3 to the third and plug it into the original, what happens? So in my original, I have 2e3 times natural log of 3 to the third plus 8. Okay? And so here, with the natural log 3 to the third, the 3's are going to cancel out, and I'm left with 2e natural log 3 plus 8. The e undoes the natural log. I'm left with 2 times 3 plus 8. That gives me 6 plus 8, which equals 14. Okay, that's why I encourage you to keep the original, the exact, and plug it into the original. You can also type the approximate in using a calculator, but the original will lead you there too. So we know that some variation of one of these is correct. Any variation. All right, our next one. So step 1, is there anything that I can add or subtract away from this term? Nope, good to go. Step 2, is there anything I can multiply or divide away from this term? Yes, I can divide both sides by 5. Okay, so that leaves me with e to the 2x plus 7 equals 24 divided by 5. Okay, now step 3 is to apply property number 2. So that gives me the natural log, and I do to one side, I do to the other. And it's going to undo, so I'm left with 2x plus 7 equals the natural log of 24 divided by 5. Okay. After that, if you would like to write this as 4 and 8/10, you can. So I have 2x plus 7 equals 4 and 8/10. And step 4 is to solve for x. So I'm going to subtract 7, and that gives me 2x equals negative 2 and 2/10. Then I'm going to divide by 2. So I got x by itself. So x equals negative 1 and 1/10. And I'm going to take that and plug it in and see what happens. Okay, so in step 6, we're going to check ourselves. So we have 5e to the 2 times negative 1.1 plus 7. We want to know, what does that equal? Oh my goodness, guys, please take this as a, I don't know why I don't keep my notes in front of me, and why am I looking at 12 a.m. But please do not drop your negative like your special teacher did here. Natural log, I was like, that did not go right, of 4 and 8/10. There we go. And then we subtract 7 from that. So we're left with 2x equals natural log of 4 and 8/10 minus 7. Then we're going to divide by 2. So our exact value is x equals the natural log of, I'm going to put a half. So x equals 1/2 the natural log of 4.8, 4 and 8/10. Natural log of 4 and 8/10 minus 7. I have to make sure that's all divided times a half. Okay, so I can put that in the calculator, get an approximate value. So in the calculator, when we plug that in, make sure if you're going to write it as a half, make sure you put the extra parentheses. If you're going to write it as a fraction, make sure you close around the 4 and 8/10 before writing your minus 7. And we get approximately negative 716 thousandths. 716 thousandths. Okay, we're going to check this by plugging it into the original. So if we plug this into the original, what do we get? We end up with 5 times e to the 2 times 1/2 natural log of 4 and 8/10 minus 7 plus 7. Okay, so this is going to become a half. The natural log is going to eliminate, and we're going to be left with 5, and your 0.7s are going to cancel each other out. We're going to be left with 5 times 4.8, and if I have 5 times 4 and 8/10, what does that give me? Dun, 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 dun. It gives me 24. Yes, that's nice. Okay, disregard the nonsense that I tried in the very beginning. All right. Okay, so here are yours to try in your notebook. So as you work these problems in your notebook, make sure you're following the steps, take your time, and always check yourself, because if you check yourself using the exact value, it should come down to what it's equal to if you did it correctly. If you have any questions or comments, please let me know or discuss this with a peer. Thank you. Thank you for pausing and coming back. These are the answers that you should have received on these two problems. If you did not receive these answers, please let me know so that we can see what we can do to make sure that you get the correct answer next time. All right, real world application, word problems. So here we have the cells of a lawnmower t years after a particular model is introduced is given by the function y equals 5,500 natural log 9t plus 4, where y is the number of mowers sold. How many mowers will be sold 3 years after a model is introduced? Round the answer to the nearest whole number. Okay, so it's giving us our t, it's giving us our function, and we have y equals 5,500 natural log 9t plus 4. And it wants to know how many mowers will be sold 3 years after a model is introduced. So we're looking for 3 years after a model is introduced. So it's in terms of t. And so we're looking for a y of 3. So we have 5,500 natural log of 9 times 3 plus 4. So we have 5,500 natural log of 27 plus 4. 5,500 natural log of 31. Okay, it says round to the nearest whole number, so we're going to put this in and find our approximate value of how many lawnmowers were sold. So during this time, it is approximately 18,887 lawnmowers. Okay, this is an example of a pretty straightforward natural log function problem. It is just simply reading, identifying what information is given, what they're wanting from you, and then going from there. Okay, remember, word problems are usually probably the easiest problems. You just have to read and have a little confidence. All right, let's check out number 2. A spacecraft can attain a stable orbit 300 kilometers above Earth if it reaches a velocity of 7 7/10 kilometers per second. The formula for a rocket's maximum velocity v in kilometers per second is v equals negative 98 10,000ths t plus c natural log of r. The booster rocket fires for t seconds, and the velocity of the exhaust is c kilometers per second. The ratio of the mass of the rocket filled with fuel to its mass within its fuel is r. Suppose a booster rocket for a spacecraft has a mass ratio of about 15, an exhaust velocity of 2 1/10 kilometers per second, and a firing time of 30 seconds. Can the spacecraft achieve a stable orbit of 300 kilometers above Earth? Okay, so I just want to point out when you're reading this problem, the beginning numbers, I know you feel like you should use every number in a word problem, but if you read this first sentence, it's just an information sentence. It's letting you know that in order for the spacecraft to have stable orbit 300 kilometers above, its velocity has to equal this amount. Okay, that's our goal. And so what this problem is asking you is, based on the given information, will this spacecraft orbit at 300 kilometers? And so first thing it tells us is the mass ratio, and our mass ratio, that's our capital R, and that equals 15. Then it says our exhaust velocity, that is our C value, and our C equals 2 1/10. Okay, and then our T, our time, our firing time, is 30 seconds. So we have t equals 30. So I have all these things, t, c, and r, these variables to plug in. So if we have v, and we want to know what is our velocity, what velocity is needed, 7.7, okay? So we want to know if what we get is going to reach 7.7 or higher. So we need this velocity to be 7.7 equal to or greater than it, correct? So I'm going to take this and I plug in everything that I have. I have negative 98/10,000 t, which is 30, plus c, which is 2 1/10, times the natural log of r, which is 15. And I'm just going to plug this all into my scientific calculator, just as it is. So in my scientific calculator, I have negative 0.0098 times 30 plus 2 1/10 times the natural log of 15. Then get a value, and it says that this equals, I'm going to make it an approximation. This is approximately 5 and 39 hundredths. We'll leave it at 5 and 39 hundredths. And so velocity is written in kilometers per second. So this is 5 and 39 hundredths kilometers per second. Okay. The thing here is answering the question, can the spacecraft achieve a stable orbit? And in order for it to achieve a stable orbit, the spacecraft has to be greater than or equal to 7.7 kilometers per second. And this is not true. It is not greater than or equal to 7.7 kilometers per second. So the answer here would be no. The spacecraft will not. Will not achieve orbit. All right, again, word problems, just got to read them. Read them carefully, read them more than once. Identify what is being asked, identify what is being given, and then identify what is needed to answer what's being asked. Let me know if you have any questions. This concludes our Unit 7. Please continue to study and prepare for your test.